Friends, in our previous session, we have learned to classify the rocks. We have classified rocks into igneous, sedimentary and metamorphic, how they recycle in nature and again sedimentary rock formed, igneous rock formed, metamorphic rocks formed. And we have also tried to understand how we can classify each type of rock, igneous rocks. There we have started. We have tried to classify them into plutonic, hypabasal, volcanic based on their mode of origin, or acidic, intermediate, basic, ultra basic based on their composition. Each one has certain advantage. Now even within the plutonic or hypabasal rocks or volcanic rocks, we can further go and try to identify different types. These also have certain advantage. We have just had the taste of the advantage of this classification. We shall go further. Friends, I am trying to present this in a sketch. I invite your memory. We have a concordant, that is sill. What is concordant? You will soon come to know. Laccolith, lopalith, phacolith, discordant dike, volcanic plug, batholith, stock. Now, in this picture, once again we try to know. Example, I have presented a stock, a boss and a batholith. You see, this is the magma chamber. From that, magma came to this level and solidified and formed a plutonic igneous rock. In this process, what has happened? It has cut the existing rock or layers and formed here. They have cross-cutting relationship. See? And then we have stocks. Stocks is in all respects similar. You see the body of the rock, the quantity, volume, and this is very smaller quantity. And this is another, see, hope you will able to read this one locally. These are small compared to this is a small igneous body. Compared to this, it is a larger. I can decide upon whether I have this type, how much quantity of rock I can excavate from a given area. So we will try to define what exactly this little later. Now from this, magma can come again and they have cut this rock. They are able to cut, intersect, discordant we call. Once on reaching this this magma may not able to cut across them, but they tend to display themselves, tend to occupy the space between different layers. Friends, if there are different layers of rock in the ground, these different layers in between there may be weak, and in that a fluid can get emplaced, get ejected into, and they can solidify. Those kind of rocks, when magma or a fluid come and they do not cut, they flow parallel to the existing structure and get solidified. We call them sill. A magma, this is a batholith, flows out, can form a sill. If there is a continuous pressure from the magma, they flow, and whatever the space they have created may not be adequate to flow further. At the same time, there is a pressure, and now with that pressure they are able to cut again. Means This is a batholith can serve as a source for sill. Sill can serve as a source for the dike. This one is the dike, and this dike can be a source for sill. They are all complementary. So, from the magma chamber to batholith, we can have simply stocks and bosses, or localith, or simply then moves up, they dike or they display like that and flow or solidify and can form sill. Or if there is a continuous pressure, they can even reach the surface, and once they reach the surface, through single fracture they all may get accumulated, or through series of fracture they may come to the surface. And this is volcano. It means these are discordant. They have cut across the rocks. These are discordant. They did not cut across the rock. What is the problem with it? You see, if the material in the ground, if they eroded at this level, these things are not exposed. They are all hidden inside. Although there is a resource, they escape my sight. If this is the case, yes, I can get. Thus, the location of a batholith, stock, etc. are hidden. These are hidden. It's a problem for us. But they are wonderful resources. If I can locate them where they are, then we are so much benefited. So, mode of occurrence poses a challenge that if they are hidden, how do I locate them? If they are of different form, yes, I am benefited how much quantity of rock I can get. In this simple diagram, I am trying to explain the different mode of occurrence and the challenges posed by them to locate, challenges posed by them to remove it in a calculated quantity, required quantity, because I have to go deeper, 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 and cost increases. Thus, this classification, which sills, laccolith, lopolith or phacolith, what are all these, I soon explain. This mode of occurrence give only restricted type or quantity of rocks, they are hidden. Whereas this, I can easily understand them, they cut across, they yield a large quantity of rocks, and their properties are also different. Because if a sill is to be formed, what should be the nature of the liquid? That liquid should able to flow between this layer and this layer. It should able to lift and make space for them, should able to flow in the sense they should be highly mobile. If it is highly viscous, they cannot flow like this. It means it is dependent on the nature of the magma. Obviously, once they solidify, a different type of rocks are formed. Therefore, if I have a sill or a dike or a batholith, my understanding about their composition, their quantity available, their excavation, their property, everything I get idea. Right? This cartoon explains those which are at certain depth, slow cooling is taking place relative to here or here. This slow cooling permits them to develop into thoroughly crystalline. Therefore, that crystalline rock, we have just explained plutonic in our previous session, what are all the qualities. All those qualities I expect here, here, here. In terms of quality, property, they are similar, but in terms of quantity, they are different. If I bring two rocks, therefore you cannot say whether it is from batholith, stocks or boss, you cannot say. It has similar property. But once I go to the site, their mode of occurrence is something different. Then question comes, how much quantity of rock I can quarry. If it is a sill, its property is different. It should be able to flow. Unless this is a fluid, highly mobile, it cannot flow. And if anything formed from such kind of magma, obviously their composition, their properties are different. Therefore, this is another. Thus, this sill have similar property, but this have different property than this, or this has different property than this. It is the property which help us to decide upon, but there are similar properties among intrusive rocks, difficult to distinguish and guess what is their quality. Yes, we can say, but what is their quantity? Difficult. Friends, through this sketch, we are trying to explain the mode and their properties and the relationship between same magma can give rise to stocks and bosses and laccolith. Same magma can give rise to batholith or sills under different set of conditions. That's very important. Once again, now corresponding to that model which just now have presented, on the ground what we have. This is a rock, that was a cartoon. These are actual rocks. You see a rock we call intrusive rocks, dikes. It is a wall-like intrusion through a fracture or a plane. If there is some fracture, they come across, and like this, see, from here it came here, and all along the fracture in 3 dimension, if I have to have like this, if there is a fracture, it comes all along the fracture, we have the dike. This is that section. This is a dike, intrusive rock. Imagine what is the width, what is the length, how much, very restricted width, 10 feet, 15 feet, 50 feet, maybe length maybe a kilometer. How much quantity of rock you get? To get more and more, you have to go deeper, cost increases. One more picture of this. Again, this is another dike here also, but its thickness is different. Depends on what was the source below them. A source must have produced some of these. Now, see another beauty, what do I get from this? A dike intruded, and the surrounding rocks are softer, and this dike intruded is hard enough, it did not undergo weathering erosion process, remained, whereas the adjacent rocks have undergone weathering and erosion. Now, this rock must have undergone weathering or this, but presence of this may block this side. Thus, they help to gain resistance locally for the adjacent rock. That phenomena we have nothing to do. It results in a typical landform. The message for us is hard rocks, these are harder than these, and they may satisfy our requirement, and these are all that kind of rocks are produced. These are the dikes. Now, just now in the previous picture, I have shown a batholith. This is batholith. I show in my previous, this is a batholith. Now, imagine in a 3 dimension, what is a batholith? Its width and length is so high, not less than 40 kilometer. A batholith is more than 40 kilometer, 50 kilometer wide distance, and their depth also not just 100 meters, several 100 meter. Imagine if I have one such a plutonic or batholith, how much I will be rich enough. I quote small example. Ilkal granite you have heard. Surprisingly, the farmer sold it because it was a rock, nothing grows. Another gentleman purchased it and he found below that some granite. And he started excavation. How long? Last 30 years. How can he run the project? Another 100 years. He is exporting, excavating, exporting. Even 100 years it will not be lost. Because what is the size of that? The length of this can be hundreds of kilometers. The depth also can be several kilometers. Huge body of rocks, if they happen to be the first class A grade gem granite like Ilkal granite, think about that, is export quality. All we find here. If I have a batholithic rock, if it can serve my purpose, attractive color, facing, decorating, etc., A grade, how fortunate we are. That's a batholith. If I have a small stock like boss-like, they are smaller igneous bodies. After some years, I have to get these get exhausted and I have to stop my activities. No more quarrying, excavation possible because there are no such rocks. Thus, now accordingly I can invest, I can have plan. So, batholith in general they are all plutonic igneous rocks. In composition, granite, diorite, gabbro, syenites, all these in composition it may vary. All are plutonic, huge igneous bodies. That is a batholith. Stocks and bosses, as we said, they are smaller dimensions, and dikes etc. are much more smaller dimensions. Lava flow may not yield a good quality material because of so many reasons which we have discussed. They can be glassy like, or they may contain lot of gas cavities in them. I show you some more slides. Therefore, they are inferior. Therefore, though we have rocks can be of smaller quantity, there are good quantities, good quality rock, there may be moderate quantity but not of good quality. All these are there in nature. We have to decide upon based on our investigation. This is some more picture of that just now I have showed. Friends, here you see this is a dike. An intrusion did not reach the ground but solidified here. How do I locate? On the surface I have vegetation, then soil cover, there are some rocks and this is covered underneath that. I have to locate them. This is a sill, again this is sill. If I have a sill at this depth, see, I may find here at a different depth, here at a different depth, depends on there may be some kind of subsidence through which the given rock material may have moved down. Example, if I have to excavate 100-meter depth to reach this rock, here if I reach some 50-60 meter, I am able to reach this rock body. My excavation cost less excavation cost more. All these are because although they were sills, should have uniform property everywhere, cost varies because of the later phenomena. This is another, you see. This is the source. It formed a sill. That sill came to the surface and flowed again on the ground, and this has this similar composition but at different places. If at the time of intrusion ground was covered, this and this have one and the same property, at the time it came there was no cover, this liquid solidify and get different properties, depends on. So friends, these are all the condition under which they formed and decides their application. Now friends, now with this background, can we classify, can we study the rocks into more detail? That is our concern. Because color decides, texture, it is nothing but mutual relationship between different constituents, different minerals, different crystals that define the texture. Structure, I have showed that layer and cutting across, all those determines accordingly I can classify them. The rocks contain specific minerals. We have yesterday said there are silicate minerals, rock forming minerals. Even among the rock forming minerals, some minerals are rich in quartz, some minerals are rich in feldspar, some minerals are rich in muscovite, or in some rock muscovite is 10%, in some other rock muscovite is only 2%. All this can happen, and they also determine the nature of the rock. Nature based on chemical composition, that mode of origin. Just now I showed few schematic sketches as well as photos. Porosity, water holding capacity. These ultimately decide the properties of any rock. In addition, I have to consider their strength, etc. For classification in the laboratory, for their application in the site, yes, we have to consider additional properties. Now, each one of it we shall try to learn little detail. Now, color, I have said, is an important property. How do I classify the rocks based on the color? Color is important. You go to market, they say red granite, grey granite, dark granite. There is nothing like a dark granite. What do they mean? That rock also has equally high crushing strength or equally has all polishing character or etc. They say black granite, green granite, this different granite. Say this is a grey granite, a light pink granite, like that. And we have moderately dark color, little more darker, it is another green color, this is deep dark, all this color. Now, based on this color, their demand also varies. People love to have this color, attractive color, or this color. People not love to have this color. Although all they have similar properties. It means color is an important property. After all, what that governs the color? If it is a pink, perhaps a mineral like a feldspar, which can be found in pink color, if they are present in abundance, the rock can be pink. If almost equal proportion of feldspar and quartz, they are of this color. Say here white one is a quartz, dark one is some other mineral, there may be a grey color, they may be feldspar like, then their color become intermediate, still darker, deep dark. This color is function of their composition, and that acidic or intermediate, basic or ultra basic is because of presence or absence of certain minerals we have already said earlier. Therefore, acidic rocks lighter, intermediate like this, basic like this, or ultra basic like this. Thus, based on the color itself, I can get idea about whether basic or ultra basic, or if you say just ultra basic rock I have, I can get what is its color and composition. They are dependent. Based on knowing one, I can say about the other. Therefore, whether it is acidic, intermediate, etc., this color code help both in industry as well. They give an insight about the minerals present. That is another important input for me. I tell you why it is another important input. Just now I said this is a pink. Pink is because the feldspar minerals are more in abundance. If a feldspar mineral is more in abundance than the other mineral, quartz, what may happen? Rock looks attractive pink, but to carve Gomteshwar at Shravanabala, I wanted that to be placed in air, and it has to withstand thousands of years atmospheric effect. Between the feldspar and quartz, I find quartz is more resistant than the feldspar. Why feldspar is less resistant compared to quartz? We will discuss a little later, tomorrow, like next session. Because feldspar is sensitive for some kind of weathering condition, I prefer those which are rich in quartz. Example, in Shravanabelagola, I have a granite, a grey color, because that is relatively less rich in pink minerals like feldspar, whereas it is relatively rich in minerals like quartz, which is little more resistant, or most resistant we can say, for atmospheric effect. Therefore, this color helps me to select a rock for purpose. Hampi, have you seen red granite they have used? No. Therefore, it all depends on where and for what we prefer the rocks. Okay. This acidic, they have silica content more than 65%. Silica, SiO2, is resistant for physical and chemical weathering. Obviously, I go for such rocks for carving, not go for, because they have this kind of composition. Silica is not that high in abundance. Certainly, I do not go because silica content is less. This rock much more less, and among these, although their crushing strength is similar, durability, their response to climatic effect, then I rate this as the best, not this one. Therefore, this qualifies the rock. We rarely find a rock, a monument, such things carved out of this rock. We find this. Therefore, this gives an insight for an architecture to select right material for right purpose, right project. Friends, we are trying to understand the color. Color is controlled by the specific chemical composition and resulting mineral composition, responsible for specific color as well as property. Yes, color is based on minerals present in it. Just now we said. We classify the color in a different term. We call leucocratic. That is a light colored. If I say light colored in the previous, I do not find much difference or much difference. At the most, if I see from a specimen, only dark spots smaller, dark spots larger. White spots smaller, white spots larger. That's all the difference I may find. But if I go for refined classification, leucocratic, melanocratic means moderately dark. Mesocratic is in between this dark and this dark. Light colored, dark colored, we can say moderately dark, and gabbro which I have shown is ultra basic rocks. They are much more darker. Therefore, this is a color, and this color is a function of SiO2 acidic or like that we have said. Now we shall go to texture. In this I have mentioned a texture, that is another property which determines properties of the rock. What do you mean by texture? Texture of this shirt is like this, texture of that shirt is like this, coarse texture, fine texture we use. What exactly we mean texture? It is true in the context of rocks as well. Texture is nothing but if a rock contains different minerals, and what is the mutual relationship between those minerals, whether all those minerals are interlocked equal in size, or all the rock constituents in the rocks are of different sizes and not mutually interlocked. Morning I was showing some minerals are like this, some minerals have like this. There is no interlocking between these two, but this have interlocking between these two. Interlocking this means interlocking is partial only among small grains, but not between small and the larger grain. In plutonic we have this kind of grains, this kind of grain, all are of uniform size but interlocking. The mutual relationship between different minerals is one factor that decides the texture. Texture is dependent on mutual relationship, and this relationship in turn dependent on the shape as well. Interlocking cannot happen even if there is one more grain like this, one more grain like this. Interlocking doesn't happen. It means texture is also not only dependent on mutual relationship, their shape as well. If they are irregular, interlocking arrangement is possible. If they are such well shaped, then interlocking doesn't happen. They may be hard, but cannot be that hard as here. So texture is also dependent on the shape of the particle. Friends, one more. Texture can also be dependent on, we just now said, it is not only depends on the shape of the crystal, the mutual relationship between different crystals, it is also dependent on the size of the particle, and that is also important. For example, in some rock, grains or minerals or constituents, particle, whatever you call, are larger, in some cases they are smaller. This may be granite, this may be granite. Here also quartz, here also quartz. 40% quartz, 40% quartz, 40% feldspar, 40% feldspar. But the size of the particle, in both the cases, they are also interlocking, here also interlocking, they are also uniform size. But what is the difference? The size of individual particle differs. That also qualifies to determine the property of the rock. I have mentioned several times that for a smooth carving, what we find in Hampi, Shravanabeguda, etc., such smooth carving, if the rocks are coarse grained, while chipping, if this grain escapes, or it is not possible to carve that wonderful structure. A rock should have, depending on the structure we construct or carve, should meet the requirement. Therefore, there are some rocks which are made up of such particles, there are some rocks which are made up of such larger particles. They do have influence. What is that influence? Atmospheric agents. This is a larger size. Atmospheric agents, the exposed surface area. Now, when the particles are coarser, we call coarse grained, fine grained. Their properties are different. Their response to weathering, a chemical process, etc. are different. Atmospheric agents can attack over a larger area. Atmospheric agents can attack only a smaller part of the area, because small grain, small part is exposed. Large grain, large part is exposed. Especially when the composition, it has different mineral. Suppose there is one mineral called quartz, one mineral called feldspar. Feldspar mineral is more sensitive. If that is a larger, that get affected easily. Therefore, the size of the material, size of the mineral, constituent, grain, crystal, whatever you call, also matters, also decides. In general, I can classify the texture into coarse grained. In the specimen itself, I am able to identify this is quartz, this is feldspar, this is, but like that in hand specimen. Often it is not possible. I require a small lens and see what it is, magnifying lens. Then it is a medium grade. Often even with my lens I am not able to say. I may have to study the section of that rock, place it under microscope and see through that, yes, this is quartz. Then I have to depend on microscope. If that is the case, they are fine grained. In general, mineral size less than a millimeter, difficult to identify. Minerals 1 to 3 millimeter easily I can identify with a pocket lens. More than 3 mm, 5 mm or centimeter I can easily identify. Therefore, texture is dependent on that. Texture is also dependent on one more property. Suppose I have a rock, entire mass is made up of crystalline matter. Another rock, part are crystalline matters, part are simply glassy material, fine grained amorphous material. There is another rock totally made up of amorphous substance like this. What do I call? Their property differs. Its property more stable, entire rock mass is crystalline. We call hollow, entire crystalline, hollow crystalline. This is hollow crystalline, hollow hyaline. Hyaline means entire mass is amorphous substance. It is in between hypocrystalline. That is part crystalline. It means it is wholly amorphous, totally unsafe, unstable condition, totally crystalline, stable condition. It stands in between them. Friends, with the help of shape of the crystal, size of the crystal, degree of crystallization, I am able to understand what exactly is the mutual relationship, and then I can define the texture. I have not defined the texture yet. I have brought out the factors that help us to decide and identify, define the texture. In general, we have pheneritic, coarse-grained minerals visible found in hand specimen. Aphanitic, not visible, commonly found in volcanic rocks, etc. These are all general terms. Perhaps with this basic knowledge, we can go further. Friends, we have tried to understand what are the controlling factors of a texture, which is very important in deciding the rock properties in n number of projects the civil engineer handles, whether it's a foundation, decorative, dimensional stone, architecture, anything. This, whatever we have said, color, texture, etc., play an important role. We shall study them little more detail.